Here's a question for you. Have you ever wondered why getting a 30-year mortgage is a totally different ballgame than, say, a 1-year loan? It's the same money, right? So why does the price, the interest rate, change so much depending on the timeline? Well, we are about to crack that code by diving into something called the term structure of interest rates. I mean, really think about it for a second. If you go to a bank, the rate you get for a 1-year loan is almost never going to be the same as the rate for a 30-year mortgage. But why? It feels like a dollar should be a dollar. But the market puts a different price on that dollar depending on how long you want to borrow it for. That's the core mystery we're going to solve right now. Okay, let's put some numbers on this to make it real. Imagine a lender offers you a loan for 1 year at 9% interest. But if you want that loan for 3 years, the price jumps to 11%. So what's going on in those extra 2 years that makes the overall rate so much higher? There's information hidden inside these numbers, and we're about to dig it out. All right, to solve this puzzle, we need our first clue. And it starts with the most basic idea, the interest rate for an investment that you make right here, right now. This is what we call the spot rate. And honestly, it's pretty much exactly what it sounds like. It's the rate you get on the spot for an investment that starts today and lasts for a specific chunk of time. So that 9% for 1 year in our puzzle, that's the 1-year spot rate. That 11% for 3 years, yep, that's the 3-year spot rate. These are our fundamental building blocks. Now, our second clue. This is the secret key to the entire puzzle. It's a little more abstract, because it's about interest rates that don't really technically exist yet. Let me introduce you to the forward rate. Now, this isn't some wild guess or a psychic prediction. It's an interest rate for a future period that is mathematically baked into today's spot rates. The best way to think about it is this. It's like shaking hands today and agreeing on the exact interest rate for a loan that will only start a year from now. That rate is already there. It's just locked inside today's numbers. And now for the aha moment. We've got our 2 clues, spot rates and forward rates. Let's see what happens when we put them together, because this is where it all clicks. So let's say you want to invest your money for 2 years. The most straightforward way is to just lock in the 2-year spot rate. We'll call it Z2. You put your money in, and after 2 years, you get your initial investment back, compounded. Simple, right? But here's where it gets really interesting. You could take a different path. You could invest for just 1 year at the 1-year spot rate, Z1. Then, when that year is up, you take all your money and you reinvest it for that second year. But at what rate? What number is supposed to go where that question mark is? And boom, there's our answer. That missing rate has to be the forward rate we were just talking about. See, in an efficient market, both of these paths have to give you the exact same return in the end. If they didn't, traders would just pile into whichever one was better, and all that money moving around would instantly push the rates back into balance. The 2 sides of this equation must be equal. So here is the big takeaway. A long-term interest rate isn't just some random number pulled out of thin air. It's really a blend. It's a combination of today's short-term rate and all the implied forward rates for every single period between now and when the loan ends. It's all baked right in. And look, this isn't just some abstract theory. We can actually do the math. If we know the 1-year spot rate is 9% and the 2-year spot rate is 10%, the math tells us that the implied forward rate for that second year must be 11.01%. That is the hidden number that makes the whole system balance out perfectly. Okay, so this is all pretty cool, but what's the point? Well, this hidden logic is the key to a huge practical application, figuring out what a bond is actually worth. Let's see how we can use these spot rates to put a precise price tag on a financial asset today. It really just boils down to this 4-step recipe. You have to look at a bond not as one single thing, but as a series of individual payments coming to you in the future. Now, the real key here is step 2. You have to value each of those future payments using the specific spot rate that matches its timing. A payment you get in 1 year, you use the 1-year spot rate. A payment in 10 years, you got to use the 10-year spot rate. Each piece gets its own rate. This example ties it all together beautifully. So this bond is going to pay you twice. The first payment, a $60 coupon, comes in 1 year. So we value that using the 1-year spot rate of 9%. The second payment, the big one, $1,060, arrives in 2 years. So for that one, we have to use the 2-year spot rate of 10%. We bring each of those future payments back to what they're worth today, add them up, and we get the bond's precise true price, $931.08. Okay, let's zoom out. We've gone from a simple puzzle about loans all the way to pricing a bond. But what does this whole collection of rates tell us about the entire economy?
You know, this thing we've been building this whole time, it has a name, and you've probably heard it before. It's the yield curve. It's simply a picture, a snapshot of all the different spot rates for 1 year, 2 years, 10 years, 30 years, all plotted out on a chart. And this is what a typical or normal yield curve looks like. The rate for a 1 year loan is lower than the rate for a 2 year loan, which is lower than a 3 year loan, and so on. This nice upward slope is generally seen as a good sign. It signals that the market is expecting the economy to grow and for things to be pretty stable. So, why is this one simple line on a graph so important? Because the yield curve is one of the most powerful economic crystal balls we have. It is the market's collective bet on what the future holds. When it slopes up, like we saw, that's a vote of confidence. But when it inverts, when short-term rates actually become higher than long-term rates, it has historically been an incredibly accurate warning sign of a recession on the horizon. And that leaves us with a pretty fascinating final thought. The yield curve isn't just a graph in a textbook. It's a story that the market is telling us right now about our shared economic future. The only question is, what story is it telling us today? Thanks so much for watching.